Well, welcome back. We still have Mars in view for you in the lower right-hand corner, but we wanted to take an opportunity to say, yes, in the lower corner,
Yeah,
look,
there it is.
we have a little screen we're looking at. But I wanted to take an opportunity to celebrate two people who are here with us tonight and introduce them to you. We probably don't need a whole lot of introduction. On my far left is Tim Russ, who, if you are a fan of space and astronomy, you probably recognize because he played Commander Tuvok on Star Trek Voyager, a Vulcan no less. And in fact, Tim was here at All Space Considered a couple of months ago, maybe about 6 or 7, 8 months ago.
It was like February, I think.
Yeah, it wasn't too long
February,
ago.
yeah.
It was wonderful to have him join us, so we're thrilled that he's here. And next to him is Andre Bormanis, who is a writer and television writer, and started out as science advisor to the Star Trek franchise way back at the Next Generation. And both of them are here because both of them are avid amateur astronomers. And I guess the first question I have to ask each of you is, how many telescopes do you have?
I've got 4.
I think I lost count after I bought my 10th or 11th.
Oh!
But,
Oh
maybe
my
a baker's
gosh.
dozen. Some of them are historic and sort of,
Yeah,
nostalgic.
there you go.
Nostalgic.
Haven't looked through them lately.
Have not.
Yeah, what do you do with 12? You don't have 12 eyes or 4 eyes.
Well, I use they're optimized for different kinds of viewing. One of them is an antique. It's an old Alvin Clark 4-inch refractor from the early 1890s. Still
Oh, my.
a brilliant telescope. And then, as Laura knows, I had a very close friend and mentor, a man that I met when I was a child, who was a brilliant optician and built telescopes until he was in his late 80s when he passed away. And I have several of his telescopes that I've collected over the years. So, yeah.
Yeah. And why? Seriously,
Why?
what
Yes.
is the draw? I mean, we're all doing it. There's this, view of the telescope here.
Yes.
What is the draw? What is it that makes you get all that glass and,
Yeah.
and spend
Well-
your nights doing these crazy observations?
By the way, we're the guys who get to follow Buzz Aldrin. So,
Yeah.
thanks, Laura. Friendo 20 years. But, no, it's a legitimate question, and Buzz is amazing. But I will tell you my story, and then Tim will tell you his. But when I was 11 years old, I was really interested in astronomy. I lived in Phoenix, Arizona. I could see the night sky pretty well back then. And so I decided I wanted to get a telescope, and I looked in the phone book in the yellow pages under telescopes. There was a company
book.
called Ad Astra Telescopes, first listing, so I called them, and I spoke to this gentleman, Max Bray, and I thought I knew what I was talking about, right? And I said, so what kind of telescopes do you make, reflectors or refractors? And he said, I make a telescope that's a combination of both. I'm like, oh my God, what could that be? So he said, have your dad bring you down to the shop one of these nights, and I'll show you. And he made telescopes like this Questar that's sitting behind us, a mixed mirror lens system. And he had one about the size of that telescope. He pointed it at Saturn, and I looked through the lens, and I saw this little white dot with this little ring around it, and it literally took my breath away. I remember gasping. This was 50 years ago. I remember it like it was yesterday. And I was hooked. And from then on, I knew that I had to do something that involved astronomy, space science, the excitement of the Apollo missions, which were going on at the time. So, I would say if any one particular moment fixed my interest, that was probably it.
Myself, I started studying astronomy on my own with a very small 4-inch reflector, a Newtonian. I decided one day I wanted to, discover and learn the constellations of the night sky, and just, teach myself and learn. At the time, there were no computers on the telescopes when I bought mine, and I took it out to the dark skies here off the 5 freeway in the north part of the mountains in the hills, and just started learning where the constellations were and some of the objects in them. And then I just, from there, graduated to larger and larger telescopes, and it was really fascinating to me to be able to see, whole galaxies and clusters in these in the constellations, and it was absolutely fascinating. And I just got larger and larger scopes so I could see more and more. And then eventually, I got a chance not only to see the planets, but also the special for me, the very special things like tonight. I mean, it would have been fabulous to not have the dust storm on Mars, but I saw it 17 years ago when it was close approach. I saw all the detail of the surface in my backyard with a relatively small telescope, and I was just blown away. So that, the collision on Jupiter of Shoemaker-Levy 9, to be able to observe that here at the Griffith Observatory grounds with a small telescope yet again, and then Comet Hyakutake, close up with the big Newtonian Dobson. Oh my goodness, those are the moments and the reasons why I have the telescopes I have and why I enjoy this hobby so much. And I'm waiting for the very next special event, whether it's a supernova or another collision or another comet. I'm waiting for the next event, and that to me is what's most exciting about it.
It's kind of amazing. There are other worlds, and they're real. It's
Yes.
not
Yeah.
CG. It's not a picture. It's not a painting.
No.
You're actually looking at
Yeah.
light bouncing off of the surface of
Yeah.
another world.
That's correct.
It's an amazing. Whoa, there goes
That's-
my mic pack. Am I still dropped my mic pack? You still hearing me? Okay. Okay, they're telling me I'm all right.
Well, and I think that's a big part of the allure of Mars, because Mars is the only planet in our solar system where you can directly observe the surface with a telescope here on Earth. When you look at Venus, you're looking at clouds. When you look at Mercury, well, it's too close to the sun to see surface detail,
Right.
even in big telescopes. Jupiter, Saturn, Uranus, Neptune, again, you're looking at cloud tops.
yeah.
Mars, we see the surface, the physical surface of the planet. We can see features that persist over time. And when there's not a global dust storm as we have tonight, but even tonight with the dust storm, you can see the polar caps, you can see a
Yeah.
little bit of the albedo features, the
Yeah.
darker so-called seas, which are just really kind of coarser dust on the
Yeah.
surface of the planet. When that storm clears, which will probably happen in the next week or two, with a telescope like the 12-inch Zeiss and even much more modest telescopes, you can see a remarkable amount of surface features. And
Yeah.
I think that's why the planet captured the imagination of so many astronomers going back to, Cassini and Huygens and
Yeah.
Robert Hooke.
Yeah.
And then, of course, the canals, the so-called
Yes, the
canals
canale,
that,
yes. And
that
the romantic,
Schiaparelli. And,
yeah, the romantic sort of aspect of Mars. Mars has been romanticized. It's
Yeah.
been fictionalized. It's been, all kinds of films and stories
Yeah.
and books, and it's just something about it. And it would have been, obviously it was at its inception and its creation in the beginning, it was a lot like Earth. It
Yeah.
was a potentially Earth-like planet, and maybe if it had been a little bit bigger, the core had remained a little hotter for a lot longer. Maybe you never know what would have been like. We could have
Yeah.
had a sister planet.
Yeah, and it's certainly, in the grand scheme of things, so much like the Earth,
Yeah.
and it's not that big a leap. I
No.
don't think that these astronomers back in the 19th and early 20th centuries were necessarily going off the deep end in their speculations, because you know what? Life is ubiquitous on this planet. It's
Yeah.
not that hard to imagine that another planet with seasons and an atmosphere and, polar caps that at the time were probably thought to be water, and
Yeah.
or a mix of water and carbon dioxide.
Yeah.
Not that big a leap to expect that maybe there was life there once, maybe there still is today.
Maybe there still is today. We're still looking.
And we don't want to be alone. We would love to find our cousins out there in the cosmos.
Certainly
Even
would.
if they're little microscopic.
Microbes.
Even if they're
Even if
microbes.
they're
We
microbes.
still it's
Absolutely.
my cousin Croby.
My cousin Kroby. Most of your body is made up of microbes by number.
Maybe
Gut
yours.
bacteria,
That's true. Yeah.
depending on your diet.
Yeah, right. So anyway, both of you. Ooh, last question. I won't keep you because Tim needs to get back to his telescope,
He's
which
gotta
is
scope.
down on the lawn. But you both spend time imagining the future and our future beyond this planet. And you heard Buzz talk about, I love that he jumped straight to the infrastructure. How are we going to make this routine? How are we going to set
Yeah.
up, essentially a subway system, a superhighway system that's going to keep all of the travel back and forth? What do you see? What do you see the future, let's say, let me go with 200 years from now.
Oh my goodness.
Is that too tough a question?
No, I
Would you
think
rather
that's-
start sooner, or
No,
should we
I-
jump all the way to 200
200.
years?
We can give
Sure.
maybe a
Hey.
stab at 200.
Okay.
The show I currently work on is 400 years.
Oh, well, we'll come to that one next.
Yes.
Because actually, after this, we're going to talk with some folks from the
Yes.
You got
Expanse,
it.
and that's set 200 years in the future,
Right.
and that has a very particular vision. So,
Yeah.
Wow.
so what do you think? What do you imagine?
I think that if our, I want to say, sort of political priorities change over that course of time, we're going to see the changes in our planet because of the resources that might be available and because of the population growth. Population growth this century is going to be a big factor. What are we going to do with all the people? What are we going to do with the resources that may be dwindling? How are we going to take care of everyone on the planet in growing numbers is as far as Earth goes. And some of the technology that's created and we come up with in advancements in science will aid in that, as long as, like I said, the political direction and intention and priority moves us in that direction and into the whole, and not so much for the individual. I think we are going to be colonizing space at that time. We're going to be living off-world, if not in orbit, certainly on another planet, perhaps Mars, as a colony, and those colonies will grow to much larger sizes, definitely at the end of 200 years. We're going to be off-world. We're going to be expanding as an Earth species, more than likely with genetic modifications and engineering to our bodies to be able to adapt perhaps to the atmosphere and perhaps the beginning of terraforming on that planet. So that's what I think I see coming. I hope that, on the planet Earth, that they're not left behind too much, and that we can work on the difficulties we have to deal with here on planet Earth.
Yeah, I would agree. I think that the expanse is a pretty credible extrapolation of what 200 years of progress along the lines of what we've seen in the last 50 years, might ultimately lead to. The thing that it seems to me people underestimate is the challenge of human beings living in a radiation environment beyond low Earth orbit. I mean, even the astronauts who spend, months to a year on the International Space Station, they are physically altered by that experience in a way that is not reversible, and it's not good. It's bad in a lot of ways, for vision, for muscle mass, for osteoporosis. I'd read recently that the Apollo astronauts were drawn from a group of people, test pilots, a large, sample of extraordinarily physically fit people whose rate of heart disease was about 4 times less than the average population. Now, this is a much smaller sample, but all of the astronauts who left Earth orbit and went to the moon, either to orbit it or to land on it, their rates of heart disease are about comparable to the general population. So that trip to the moon, which was no more than a couple of weeks, apparently quadrupled their chances of suffering from heart disease. And I don't know what other kinds of, measures people have looked at, but it's an extraordinarily hostile environment outside of the Earth's protective magnetic field and atmosphere.
Certainly is.
And cosmic rays and other forms of radiation, extraordinarily debilitating. And I think that that's going to be the biggest challenge going forward in the near term, is dealing with those issues. And that might be a genetic engineering challenge more than anything else.
Dare I say tardigrade? The word tardigrade.
Dare you say tardigrade?
It's out there, man. They know that. They know it. The tardigrade. Everything about those little monsters. You take the DNA, you splice it into human, and you are out of Dodge, man. That is the only way it's going to happen.
Makes you wonder where they came from.
It does make you wonder where they came from, because to me, they are the most amazing microbial creature on the planet, bar none,
and
I think.
And they look like aliens, too.
And they look like aliens, just to finish it out.
Yeah, exactly. Well, it begs the question, we need to do more research in orbit. We need to understand, and that, of course, is one of the purposes of the International Space Station. And, I think that research has got to be, ramped up. We need to really understand that if this vision is going to come true.
Yeah.
I just want to thank you once again for joining us here, and I hope you enjoy the rest of your evening. I mean, this really, you could not ask for a more beautiful night.
It's a lovely night.
Absolutely
just
gorgeous.
Breathtakingly beautiful night.
Wonderful.
So it's something to look up there and think, well, maybe someday, our descendants will be up there.
Our robotic representatives are already there. When you look at that planet, think about the fact that there are several spacecraft on its surface functioning.
Gathering data.
And a half a dozen or so in orbit.
Yeah.
And maybe some tardigrades.
Yeah, and maybe some tardigrades. And who knows what else.
Right.
A little fellow named Marvin.
That would be
amazing. And one guy named Marvin.
One guy named Marvin.
In a Roman soldier outfit. I just don't really quite get it. Whatever that outfit is.
Marvin.
So, so anyway, thanks again, both of you.
Very
so
good.
lovely to see you both.
Our pleasure. Thank you for having us, Laura.
We'll be
Appreciate
back
it.
in just a few minutes with more guests. The next one from JPL. So enjoy a few minutes of Mars and music.
Thank you.